So we're going to finish this problem now. Now that we've reached halfway to the equivalence point, we are now going to focus on at the equivalence point and then a point beyond the equivalence point. So again, this is a weak acid with a strong base. Same idea in terms of how much you need to put in there. So again, the equivalence point, I probably will not give you the volume. So you're going to have to realize that the volume is going to be, again, a kind of a 1-for-1 for the amount of acid to the amount of base. So at this point, the hydroxide concentration is the same as the complete acid, so the acetic acid. That is exactly the same, but you have made acetate at the same time. So you cannot say the pH is exactly at 7 for any kind of weak with a strong. So again, going back to the other idea or the other lecture, this is an equilibrium reaction. Okay, this is an equilibrium reaction. So therefore, I have a Ka to look up or a Kb to look up. In this case, it is a Kb because I produce hydroxide ion. So I would look up a Kb and I would then find the pH that way. So the pH for this one happens to be 8.790. Again, you would have to look up the Kb value of acetate. And again, this is now the salt component of this titration. So since this is a weak acid, your pH is going to be greater than 7 at the equivalence point for any weak acid titrating with a strong base. If you are doing a weak base, your pH is actually going to be less than 7. But that's what makes it different in terms of the titration versus a strong. And finally, we have 30 mils of NaOH. This is 5 mils past the equivalence point. So just like I did before, I'm just going to look at the 5 mils. I'm not going to go all the way back to the beginning. So here I have a strong base of the NaOH, and I have the acetate ion, which is going to make it basic as well. But realize that this is going to be in a small amount. So since it is in a small amount, really what I should focus on is, of course, the strong base. The strong base is going to give me really the pH. Yes, you could do all of the work, but it's really not necessary. So 0.005 liters of the base times its molarity is going to give me my 0.001 moles of OH. So very much like the strong versus strong, I just got to take it over the total volume, and then I have 0.0125 molarity as my hydroxide concentration. So when I take the negative log, it's going to be the POH, which is 1.90. Again, it should click in your head that that is not a pH of a basic solution. So finally, my pH is at 12.10, which again is going to be at the same place as you saw with the strongs. So really, the only difference you see with weaks is going to be this area here. It's going to start at a much higher pH, and this is called the buffer region because this is where you use Henderson-Hasselbalch equation. Okay, so this is your buffer region. And this is going to make the calculations slightly different. But look, the equivalence point is somewhere above pH of 7, but the volume is going to be, again, in this case, it was at 25 milliliters. So it's exactly the same place as you have with the strong. That's going to look no different. It's just this region here is going to be slightly different. Let's see. So it does not matter if this is a graphing it. Oh, just to make sure I put down all of the points I want to put down. So pH, again, if I am doing the graph of a weak base with a strong acid, so I'm going to look at this for this graph, I will see that the strong acid is down here in terms of milliliters. What you would see up here, and I have a hard time drawing it sometimes, so it's kind of like a weird looking S curve. But what you will see here is the equivalence point is going to be less than a pH of 7. So this is your equivalence point for a weak base and a strong acid. Again, here is the weak base. It's going to start up there, and then somewhere in the middle here, when you're about halfway, you are going to have what you call your pKb. Okay, so again, it is halfway to your titration completion here, so halfway to your equivalence point. So this is going to be where your base equals your acid. And again, that's going to be the same volume no matter if it's weak or strong, but what's going to be different is the shape of this curve here. Up at the top, if you're starting with a weak base, but then it goes straight down and then across, and this always ends up at the same place that a strong acid would as well.